Basically, what we wanted was to downsize. We live in a fairly large double house now. As we wanted to downsize to something smaller that would be more handleable, that would be more economic. We originally we wanted something like a bungalow. We've got a rather large garden, and we thought, well, why not a small bungalow in the garden? And so we started to look at what we would want from such a building. Green Building Store, we're talking about passive houses and the effect of them and all the theory of them really. But what's primary for us was the practice of them, and that's why we went to Austria, and that's why we found it invaluable to see see the culture that already exists in Europe and in particularly Germany, in Austria. That in actual fact there's thousands of passive houses already built. Each of these passive houses carries lessons and carries developments that we can dovetail into. And the things we've noticed is that the quality of build that's going in there's the insulation, which is very high. There's the air tightness, which it needs to hold in the energy. What it needs is the quality of build to make that happen. I think again we've fallen on our feet with the Green Building Store because they are bespoke builders that can produce builds to a very high quality because it needs to be high quality to make it work. And that's the cultural shift. There needs to be a cultural shift in the UK. Using cavity wall as that's the standard building practice. And all that the Green Building Store are really doing is actually taking a standard practice and making it more efficient by quality build and attention to detail.
Passivhaus is all about saving energy. It's like making the building perform, making the building fabric perform so that we minimise energy loss from the building. And particularly we're looking at addressing insulation, we're looking at thermal bridges, air tightness of the building, looking at the ventilation system through mechanical ventilation with heat recovery and optimising solar gain. Passivhaus grew out of work done in the 1980s. There was quite a lot of experimental work being done on super insulation, on using solar gain to heat buildings. But what was being found was that the buildings weren't performing as they should do. Wolfgang Feist is a physicist, and he really wanted to look at why buildings weren't working and look at the principles. And this is what he did. So he went back to basic principles of building physics and eventually put what he'd worked out from that into practice in a row of experimental houses in Darmstadt, which were built in 1991. And Dr. Feist still lives in one of those houses, and they really do work. They've been monitored extensively and they're still performing well. Dr. Feist knew that super insulating a building was not enough, that we can add lots of insulation, but if we don't attend to other measures, look at the rest of the physics of the building, that the buildings don't perform properly. And really what he did was look at all of the measures needed to make the whole package work. What he also did was looked at the emerging science of or understanding of comfort in buildings, particularly work done in the 80s by Fanger, to understand how we experience comfort and how to make a comfortable building. And he combined that with the various measures needed to make an energy efficient building. So Passivhaus brings together comfort and energy efficiency. Super insulation, and we're using high levels of insulation. So we're going up to typically 300 millimetres of insulation for fibrous insulation. So this is beyond what many people thought was sensible. Right? We combine that with removing thermal bridges. So we need to wrap the whole building in insulation. So it's no good insulating parts of the building and then having thermal bridges because we're wasting a lot of that insulation. And particularly when we're going to high levels of insulation, the thermal bridging becomes very, very significant. We need to look at air tightness. If a building isn't airtight, however much insulation it has, it won't perform properly. The air will move through the fabric of the building and a lot of the gain from the insulation will be lost. So we need to ensure that it's a very airtight building, and passive houses are very airtight. We also need to look at ventilation, because when we have a very low energy building, ventilation can account for half of all the heat loss. So we can't naturally ventilate because there's too much heat loss, and also with a very airtight building it's doubtful that we can get adequate ventilation. So we need to use mechanical ventilation with heat recovery, and that heat recovery needs to be at a very high level. So typically in a passive house, we're recovering something like 90% of the heat from the ventilation air, from the outgoing air. We also need to look at free heat from the sun, from passive solar gain. And a passive house is designed to optimise the amount of solar gain. So we will have larger windows on the south side particularly than on the north, and that will be optimised. So we want to avoid overheating, but we want to get the optimal level of solar gain, particularly in the colder months of the year. Comfort is obviously important. We don't want low energy buildings that aren't comfortable. A passive house is comfortable, and it's comfortable because the understanding of the science of comfort has been built into the standard. So a couple of examples to give you an idea of what we're talking about. If we've got thermal bridges through the fabric of the building, then we're going to have cold spots on the inside of the building. Now we know that cold surfaces will make us uncomfortable. We know that if there's a difference of more than about 4 degrees between us and a surface, we start to feel discomfort. Another example would be windows. We're always in danger of the inner surface of a window being colder than the rest of the fabric of the building. So the standard set for windows in a passive house relates to those comfort criteria to ensure that the inner surface temperature of the window is at least 17 degrees centigrade. Perhaps the most important criteria for a passive house is the amount of heat needed through the year. And the standard is set in one of two ways. Either the total annual heating load per square metre, which is set at 15 kilowatt hours per metre squared per annum, or the heat load, which should be no more than 10 watts per metre squared. These figures derive from the basic principle of a passive house that the heat load should be so low that the heat can be delivered through the normal ventilation system. The standard was set at this level because at this point we can deliver the heating through the ventilation system, and therefore we can take out the peripheral heating system, so we can take out the radiators. So there's a saving in cost at that point. A key feature of passive houses is that they're quality assured. So we don't just tick the box to show that we've done things. We actually have a full certification process that ensures that how we've designed the building will actually perform as expected. It will be built as expected and perform as expected.